Welcome to a question in which we're being asked, the population of a bacteria is growing according to this model. Estimate when, that's the key word, when the population will exceed 1713. So, all right, let's write this out. So P equals 550 e to the 0.16 t. And they're saying, when will the population exceed 1713? So I'm going to take 1713 and let the population become that number, 1713. So I now need to solve for t, right? Solve for t. So, it's kind of like, if it's helpful to you, it's kind of like there's a wall of separation. You got the left side over here, the right side over here. And t is saying, I want to be alone. Get rid of this 550, get rid of this e, get rid of the 0.16 so I can be alone. Find t, find when. How do we do that? Well, I think you know the first step. Divide by the 550. Boom, boom. And I'm just going to leave that left side 1713 over 550. Rather than some decimal, I don't want any decimals. I'll just leave it like that for now. Okay, so get that. Now, how do I get rid of that e? What am I going to do? What's going to happen? Well, it's, you can't, you might think, well, just divide by the e to the 0.16, but that's not going to work. Cancel this out. No, that's not going to work because that t is in the power zone. It's not multiplied. If that was times t, like on the regular level, then you could divide, but no, that's not the case, right? That t is up in the power zone. So we have to do natural log of both sides. That's in fact why logs were created, because let me write that. When the t is in power, you ln both sides. That's why logs were created. They're the inverse function of exponentials. And then what happens with that? This whole power drops down. And so we get, remember, that's the third property of logs. Remember, property 3, we had log property 1, 2, and then log property 3 said the log base b of x to the p, the power can drop down. Remember that property? So that whole power drops down. We have the ln, I'll keep the same color if that's helpful for you. ln of e. The other side, not much has changed. It's nothing has changed, in fact. I'm just going to leave it just like that. Okay, the power is dropped down. Let me get this out of the way here. So the power has dropped down. Now we're almost done. Extend this wall here. And what are we going to do? Last step to get, not last. What's ln of e? It's 1. You can check on your calculator. ln of e, it's just 1. So they just cancel each other out. So now we have 0.16t, and the other side, we have ln of 1713 over 550. Last step, divide by the 0.16. Whatever you do to one side, do the other. Boom, boom. Once the whole trick then was when we had that t in the power, ln both sides, and then the log property 3, that power drops down. And once it, and then ln of e is just 1. So then you can just divide. So t will equal, now you got to hit the buttons on your calculator. So just get this whole answer first, on your calculator, then divide by 0.16, and you will get this answer right here, 7.1005. 1005. I don't know how many decimals they want. They don't really, one decimal. All right, so 7.1. 7.1 is good enough. 7.1 what? 7.1. I don't even know what the time units are here. Anyway, good enough. 7.1. That's what you should get in your calculator. And so there is how we do the problem.